Sweepy! What's that you're sweeping up there? Oh, it's some magma! Welcome back, my fellow duplicants, to Oxygen Not Included. Today, we are taking a look at taming a volcano using little sweepy bots. So I've kind of made up this little contraption right here just as a concept, and we're going to expand on that today. So essentially what we have going on over here is a sweepy that is sweeping up liquid magma. Okay, magma is always liquid, but anyhow, magma. And the auto sweeper is pulling it out of the dock and then putting it into this bottle emptier over here on the left, which at that point will then heat up some steam and run the steam turbine. Now, if you remember from the last couple of episodes here where we were sweeping space with sweepy bots, we noticed that the output temperature of the material that was being delivered to the sweepy docks here was at a set amount. So we were actually deleting a lot of heat when we start to consider that this was over here at 300 degrees Celsius, but by the time it gets over here, it's like at 20 degrees Celsius. Really interesting. So in this arrangement here, we're actually using the regolith to keep the robo miners cool. Sort of. This design sort of works. So the idea here is that we can tame a volcano, get the power out of it, and then cool the material back down to a reasonable temperature to use inside of our base. So that's what I'm looking to explore. If this works, we should be able to tame magma volcanoes and metal volcanoes all with the exact same setup. All right, slight technicality with this one. The action of pulling liquid out of the sweepy dock and then loading it into the bottle emptier is kind of an unwritten side effect of having the canister fillers mod enabled. I didn't notice that I had this one enabled, and I didn't read that that was actually a side effect of it. So you do need that in order to make this arrangement work. However, there's another way to deal with it, and that's if we use a mechanized airlock over here. We've actually used this in the past in a couple different designs to kind of sequence magma out of this area, and we can use some of the new setups here to make this happen as well. So what I'm using here is a filter gate, and then I'm using something like a timer sensor right here, where you have 1 second of green and 10 seconds of red, or you can kind of play around with this. And what this is doing is it's just letting the mechanized airlock open up for just a moment here, letting the liquid flow in. However, you don't get to have the fun of having a little sweepy over there. Plus, the amount of magma that's left over here at the end when this thing goes dormant after a while, it's going to be a fair bit more than when you're working with something like a sweepy. Because sweepy just cleans it all up. Anyhow, so just a heads up, if you're not using mods, this arrangement here unfortunately will not work. However, this arrangement will work. Although you might want to tweak it and actually bring the volcano a little bit closer to the door if you want to get all of this liquid out. Still, that works just fine. All right, so if we take a look at this design here, there's a couple of things that I definitely want to include in my final setup here. And the key thing here is that we have an auto sweeper that can reach through this little corner gap right there and then get over here to the sweepy dock. Now, if you know that if we can reach to this tile right here, we can actually pick up out of the sweepy dock. The same thing goes for delivering to the bottle emptier if we can get right down to this tile. So this arrangement right here where we have the auto sweeper up in this spot works. We can reach down there and we can reach over here without the heat being able to get out of here and into this area. So that's kind of key. The second thing I want to do is make sure that we don't put too much heat into a chamber over here on the left. So I'm going to make sure that this only runs if we're below, let's say 195 degrees Celsius. That way we don't end up burning up too much heat because we're running the steam turbine too hot. So we'll automate this just a little bit here so that we don't bring in more magma if we don't need to. Now, as you can imagine, we are sweeping out a lot of this igneous rock once it just cools down below that 1,400 degrees Celsius that it would normally be. So I'm thinking here we would then run this to a second chamber where we're going to have a conveyor rail like this, and that'll essentially be a cooling loop where we're actually going to cool that down from 1,400 degrees Celsius down to below, again, 200 degrees or so. And the cool thing about this is we can do this all in vanilla now because we can actually put a thermal sensor on the rail right here and detect whether or not the igneous rock has become cool enough. And then the final step there will be to deliver the igneous to a chute and then run it through a sweepy where it will sweep up, deliver to a dock, taking away that extra hot material, and then we can kind of use that cold igneous rock at this point to probably cool things like the steam turbine and possibly some of these auto sweepers if they need not. So this should be possible to do with steel. So let's see if we can come up with an arrangement that'll work. So first thing I'm going to do here is just do this number, and I'm going to give it a little extra tile here on the right and left. All right, so here we have our volcano, and now we're just going to have some space for that to go down there and for our Sweepy bot to run around and do its thing. Now, you know what? Our Sweepy bots really only require 1 tile tall. Maybe, just maybe, we can get away with doing this number. Now for this design, we're going to be using steel for all of this stuff. That way it has a meltdown temperature that's hot enough to where the volcano actually will not destroy it. All right, so the thing about the Sweepy docks and the Sweepy bot itself, in the current version of the game, they don't have an overheat temperature, and they will only melt down at the temperature at, based on the material that you build it with. So the high temperature versions of these with steel or tungsten or something like that can withstand the temperature that's the volcano puts out. So they'll get hot, but they won't melt. The other thing is though that you're going to have to power it up using something like steel wires and whatnot, so that doesn't melt. And then the raw material that you supply to the dock has to be made from the correct material. So in this case, we're actually going to go ahead and use a little bit of steel. So you can see here the Sweepy dock requires 25 kilograms of refined metal. And if we use steel to supply the creation of this bot, you'll see that the actual Sweepy bot itself has the overheat temperature of 2,400 degrees Celsius. If we were to supply it iron or something like that, our bot would actually melt when it goes into the magma. So you got to be careful of that. Ooh, this side might be a little bit more challenging. Because it isn't the same spot. Oh, okay. It does not look like we can actually set up 2 of these. I can't seem to find a spot where that would actually work. All right, so we're just going to work with the one singular bot. All right, so if I make the bottle emptier here out of obsidian, again, it too will not melt. All right, now there's a chance that we're going to get some solids over here on the right, so I want to make sure I have an out for that material as well. So let's go ahead and put a conveyor loader over here as well, just in case I do have to deal with that. Maybe this is where I put the mechanized airlock, so that we can actually get into here, do the construction that we need to do to build this thing. All right, so now that we have the bottle emptier, we're actually going to be dumping the magma out of here. So in this scenario over here, I'm kind of using like a little waterfall method. I don't really think that that's necessary. It seems like everything that needs to happen happens right here. So I think I will avoid making that any more complicated than it actually needs to be. And maybe even just flipping so it drains off to the right. All right, so as you can imagine, we're going to be draining magma out of this little bottle emptier right here. So the real question is, how quickly does it run? So if we just run this at normal speed, mop that up real quick, I'm guessing it runs at about 10 kilograms per second, or pretty close to that. Yeah, that seems about right. Something about like that. All right, to make this thing actually buildable, I'm actually going to go ahead and use obsidian in all of this spots right here, because they're not quite as critical. Considering this is going to be a vacuum, there's a good chance we won't even have to worry about the temperature to begin with. However, all of this down here, since it is double layered and we are dealing with magma right there, this is made out of insulated ceramic. So obtainable for sure, but a little less expensive. That is going to protect too much heat getting down here to the steam turbines. All right, so right down here, we're going to have 2 steam turbines. That should deal with plenty of heat. And then we've made this a little bit taller here because what we can do now is we can go ahead and use a power station inside of here. Recent update actually allowed the power station now to affect the steam turbine so that we can get a little bit extra power out of these. So we'll need to be able to get inside of here. So let's just go ahead and give it a door, and there we go. So now this room here should be a power plant. Yeah, there we go. Cool. Okay, so now that I have this magma here, it's going to be quite hot over here on the left, and I need to kind of move that heat around. So I think I'm just going to go ahead and use gold tiles to do this number. Create like a little spout, just like so. I think that'll work. So the magma will come down here. It'll hit this tile, and I think that'll kind of spread the heat out a little bit here. This is gold, and gold is going to be able to transfer the heat within it very, very quickly. So that's why I'm using gold over anything else. And then we're actually going to dump the liquid down next to the part where it's probably going to be the hottest, in what might be a decent attempt at trying to keep the temperatures somewhat even. I don't know. We'll see. I'm sure there's plenty of experimentation that we can do right here. Plus, this might be an opportunity where oil will actually make a difference. But for right now, I think that's going to be all we need in this area. The other thing that we want to put down here that's going to be really important is going to be an auto sweeper. We need to be able to pick up the igneous rock whenever we get enough of it, and we need to load that into kind of a shipping rail. Oh, and it's going to be hot, so we can use this shipping rail over here to kind of push some heat back into these metal tiles. I'm guessing this is going to be plenty hot over here, so let's just kind of do this number. All right, so to set up more turbines or to just circulate igneous rock around and around in this area. The thing is, if I circulate it around in this area, it's going to overheat the steam turbines because I don't have any way to kind of control that. So there's probably going to be some tweaking here. But let's go ahead and send it to a second chamber where we have more turbines and we're producing even more power. And just like before, we're going to have this power station thing. Awesome. And we can do that number just like so. All right, let's change up the shipping rail here. I want this to come over and then go back, jump from here to here. All right, so right down here, we're just going to have a cooling loop. So this is going to continue to run around and around. And once it reaches a cold enough temperature, then we're going to let it kick the material out. So that will go in here just like so. Kind of doubt this machine here will survive, but we're going to try it anyhow. I tell you what, in an attempt to actually keep this machine here from melting, I'm going to put it over there because I'm trying to make that out of steel. All right, so if it is cold enough over here, in this case probably below 190 degrees Celsius, then rather than continuing to go around and around inside the loop, it's going to kick out. And we're going to leave this one tile right there, just like so, and then connect it up here like that. All right, cool. So the liquid discharge in this situation is going to happen right down here. Okay, so at this point, the temperature should be relatively cold. It might be right around 400 degrees, or it might be closer to 190. Kind of depends on how efficiently this setup here works. But once we're through there, we should be able to drop down all the material over here and then let a Sweepy bot pick it up. And then at that point, that's going to cool it back down to kind of around 20 degrees Celsius. So at that point, we can put a little Sweepy dude right down here, and we can work on just shipping this stuff back out. So I'm just going to set it up to where this auto sweeper here can only pick up out of the Sweepy dock, and then we'll throw it inside of a loader. All right, so now we got to deal with the power. Now, each one of these is 850 watts. However, if we boost that, I believe that goes up to a 1,275 watts at its maximum output. So we actually have a lot of power that we're trying to move through this. I think it almost makes sense just to use heavy watt wires inside of here because we are delivering so much power. So rather than having that right there, I think I'm going to go ahead and take the conveyor rail over here like this and then bring it back. And then use this area to transfer power. So we'll use heavy watt joint plates through this. So in this area, we'll use some heavy watt joint plates just like so. Boom. And then run that in and build it up. There you go. There we go. Now we can get all of this power out somewhere. All right, so here's the power grid. It really doesn't actually use that much power. You know, possibly 1,300 watts to run all of this stuff, but honestly, it won't run that often. Just a couple of Sweepy docks. Those are the only real big consumers there. All right, so let me just set everything up here. The conveyor loader is going to be set to all in both situations. This liquid is going to be set to all. We're going to set it to a higher priority than the Sweepy dock so that the auto sweeper wants to pick it up out of here and deliver it over there. All right, so there was one more thing that I needed to do here. So this is hopefully nice and cool, and I want to bring it up and run it through this area over here, just in case the auto sweeper gets too hot. So we'll bring it up here just like this. Boom. Oh, you know what? Let's go ahead and just drop it right there. Also want to make sure that this loop has a direction, so it's going to be that way. All right, so there we go. Now, as far as what I'm going to do with the water here, I'm just going to put 400 kilograms into each zone. So that's going to be 400 here and 400 there. That will turn to steam, and that's going to be the only thing in that environment. And then I'm going to try to fill these just with oxygen to see if the steam turbines will be all right with that. Same thing goes for this chamber down here, just a little bit of oxygen, maybe mixed gases or whatever. And out of curiosity, wonder what happens if I put oxygen up here. All right, here we go. Whoa! Whoa, whoa, whoa. That's happening fast. Sweepy! You're drowning in magma! Okay, this thing is emitting 376 kilograms of magma per second right there. That is a lot of magma. Look at little Sweepy Bot, though. How much do you have on you right now? 178 kilograms of magma and a bit of ceramic as well. Holy moly. That's a lot of magma. But we have 16 cycles to make use of all of this magma. Awesome. Okay, I kind of take back the whole part where I said this is made out of obsidian. That's probably not a good choice right about now. That should probably be made of insulated ceramic and double wall right there. So let's just quickly correct that. Ceramic. Maybe just do this number 2. All right, there we go. I'm happier with that. Ooh, okay, so here we go. Now this bottle emptier is dropping the magma down here. Oh, okay, that's the one thing I forgot here. What I need to have down here is a thermal sensor. I gotta find a good spot for this. Maybe right here, maybe right there is a good spot for it. But what I'm looking to do here is to disable this, this auto sweeper, if the temperature down here is too hot. Our favorite lawnmowers are back, by the way. Let's say if this is below 200 degrees Celsius, as you can see, it's currently at 150 degrees, then it's going to be enabled. Okay, interesting. This water here is not interacting with the conveyor rail. I thought it would actually affect this. Nope, I guess that is not a thing. So let's make that double thick then. Let's brush in a little bit of water here. We should see the temperatures here go up. Yes, there we go. So what we can see here is that we're now bringing in all of this igneous here. We do have a little bit of steam. You can also see the temperature of the igneous rock that's moving past this thermal sensor right there. There we go. See, now it's running. All right, so here's what's happening over here. The igneous rock that is here is on the rail, and it's still a little bit too hot. So this arrangement up here is not working out quite as well as I would hope. So I'm going to have to make a modification to this. All right, sorry about the lawnmower. It's just making all sorts of noise in the background. All right, so here's what we can do. The problem is that we get igneous rock and it is staying right here. So what I really want to do is disable this auto sweeper if we already have material staged. So I can go ahead and use another little bit of sensor right here. So I can look for an element on the rail. You can set it to be that spot right there. And then use a NOT gate to send the correct signal up to the auto sweeper there. All right, so it's looking for igneous rock. It says it found it, so therefore it's sending a NOT signal to this. All right, you know what? This is actually working out a little bit better here. Ooh, okay. All right. So what I did over here is I changed this to be below 170 degrees Celsius so that it had a little bit more range to work with. And because we're already detecting this, the auto sweeper is staying disabled quite a bit longer. So therefore we're not delivering too much to the rail. We're not leaving that really, really hot stuff just sitting there or sitting inside of the conveyor loader. Oh, okay. Okay. It's getting awfully close to the 275 degrees though that it could potentially run at. Temperature wise, it's definitely hotter over here on the right. It kind of makes me wonder if I should be doing something different with the liquid. Like this. These things are overheating again. Hydrogen did not make enough of a difference. You can see that I do have igneous rock on the line here, but it's at 50 degrees Celsius, and it's really not. It's not going up that hot. So using igneous rock on the line here to keep the steam turbines cool doesn't seem to be working. It might be doing enough to keep these cool, but not enough to keep all four. But you know what? What if we did something different? What if we created a cooling loop, a continuous cooling loop inside of here using these conveyor rails? So what if I gave this an element sensor and then a conveyor shutoff right here? Now the thing about what I can do here is I can detect how much is on the rail by running it through a filter gate. All right, so check this out. If I use automation, I can run this through a filter gate and it will have to detect igneous rock for long enough. And if it does, then at that point we can actually kick some of it out. Otherwise, it's just going to keep looping around and around. So if I count up the amount of rails I have here, I have something like 22. So if I go to the automation and I say, let's try to keep 15 of them on the rail. Let's see what happens. So you can see that igneous rock, yeah, it's just staying there. Yeah, look at that. All right, so it's just collecting this. Nice. And as crazy as this sounds, this... Oh, I thought it was keeping the temps down. Okay, so here's what you do. Right? So we're detecting a certain type here. And if our line is pretty much maxed out, then we let it do its thing. Otherwise, the other thing that we want to do over here is to have a thermal sensor. So if we're above a certain temperature, then we want to kick it out as well. So we'll say in this case, if it's above 70 degrees, then off it goes. All right, that was interesting, but it isn't really working. Plan C. So plan C is I'm going to take some steel or metal, essentially something that's far more thermally conductive here, and end up running that over and over through this rail system. So that we get a bit of igneous rock, but we're also getting a lot of metal, which is going to work to cool the steam turbines. I'm not giving up on this idea yet. Watch this. Inside of here, what I'm going to do is put a little bit of gold. What do we have there? Ooh, 435 kilograms. That should work. So we're going to ship gold on the rail. That is going to take a lot of the heat out of the air. Watch this. See how much that... Hey, come on. You know you want to do it. I think I'm going to have to add another checkpoint. Oh, let's see. Let's just let it go. So the gold is shipping around. You can see that it's quite hot, doing its thing. This is looking for anything that is gold. And then at that point, it's going to ship it back down to the bottom where the Sweepy bot is going to cool it. Anything that is not gold will be shipped out. And then right down here, it's just reinserted. The bot picks it up. Oh, it seems like I might want to add a second Sweepy bot down here. All right, actually, I'm going to modify this just a little bit here so the Sweepy bot runs a little bit faster. You know what? That needs to be tweaked even more. All right, so the little guy's doing a lot of work, but he can only go so fast, actually. So it seems like that's about as quickly as I can move this stuff out of there. All right, so this one Sweepy bot is nowhere near fast enough to make all that work. Let's see if I can multiply it a little bit. There we go. We'll fill this whole area with Sweepy bots. Bring in the conveyor rail, and I'll split it just like this. And then I'm going to block off the top of this, so hopefully my sweepers don't accidentally look down there. Oh, darn it, they do. Oh, there's a spot right there. There's got to be a way to do this. Maybe this is the trick. Nope, haven't found it yet. No, Sweepies! Yes, there we go. That's the arrangement. And then if we use the auto loaders here, we should be able to ship it right back out. Now, how to get the rails set up? Well, we need these two to be together like this and together like that. And they too need to split. So that has to come up here like this, and then we fork it off like that. There we go. So now it will evenly divide them into all those spots. This one could just run over there like so. And then that one could just join that line, and I think we're good to go. Power-wise, okay, there's a lot more things to power down here. Okay, we're gonna put a bunch of gold in here. There we go. We just have a bunch of bots fighting over it. And then hopefully this will cool things down enough to get these generators up and running again. Let's see here, we have a bunch of gold coming in. It's getting dropped and then it's shipped. There goes a little bit of gold at 28 degrees Celsius. 22, 22. Yeah, not bad. You know what? Gold is probably the wrong material to be using. Let's eject it out of here. I want something with a higher specific heat capacity. I think diamond's going to be a good candidate for this. This is such a strange way to deal with anything. Come on, Sweepies! You can do it! I'll be honest with you, the Sweepies are not keeping up with the heat that the turbines want to kick out. Nope, this just isn't working. Alright, so far what has worked, everything out of here up until the point where we have to keep the steam turbines cool. So, we can go ahead and just get rid of all of this. We don't need that stuff. We'll just roll with one Sweepy. Oh no! And we can use that to just kind of cool the stuff down and ship it out. Not a big deal. We can even just use a dispenser, just like so. So you can see everything that's coming out here is nice and cool. That'll save us a lot on all the conveyor rails. We really don't need all of these. So we can get rid of all of that. And we'll see if we still need to run it past this little guy right there, or not. All right, now we need to deal with the heat inside of here, so Let's go ahead and do that number. All right, so I've gone ahead and set up a more traditional cooling loop here. So we have the crude oil flowing through here like this. And if it's above a certain temperature, then it's just going to be cooled and drop in here. Otherwise, it just goes on by. So that's set to 50 degrees Celsius inside of there. And as you can see, it's keeping the steam turbines nice and cool. They're nice and happy. And everything else is starting to run and run well. So now let's see just how much igneous we can get out of here at a relatively cool temperature. All right, so we can see a dramatic difference in the temperature down here. This one over here is really cold, and the one over here on the left is too hot. So I think splitting up the liquid flow there is a good idea. Ooh, but this over here, this got too hot. What does it contain? Iron ore. Woo. All right, so it looks like I might want to include this stuff up here in the cooling loop. I was kind of hoping I wouldn't have to do that. I do need to do it. This shipper isn't even doing anything, so let's just get rid of that. Honestly, it has no purpose. All right, so again, I'm kind of running into a little bit of temperature problems here. I think I'm gonna have to try water instead. Crude oil is not quite as effective. All right, so to hopefully deal with my temperature problems once and for all, I'm going to use polluted water instead of crude oil. That'll give us a little bit more temperature range than just the normal clean water, and it does have a higher specific heat capacity, so it should be a little bit more effective. All right, there we go. See, that's working a lot better. Now let's take a look at these temps. Much better. 60 degrees, I can work with that. Hey, look at this. We have over 1,000 kilograms of igneous rock right here at 27 degrees. All right, so things seem to be running stable, so I'm going to let this run for a few cycles and see what kind of numbers we get here. Oh, you know what? I just thought of something that might make this a little bit faster. If we deliver some over here, then the Sweepy collects on both sides. Delivers, sweeps it up, delivers. Aha! Increasing my production volume. Nice. All right, so I've let this run for 2 cycles now, and we have a total of 3,300 kilograms. So it seems as if one little Sweepy dock down here can do about 1,650 kilograms per cycle. So that's kind of the cooling rate here, to go from about 300 some degrees down to 20. Aha! So I was editing the video and I was looking at this spot and I'm like, you know what? I think I came up with a better idea of how to make this Sweepy run a ton faster. It picks up when it goes over this, and then it keeps moving, and then it hits a wall, comes back, and it picks up again. However, if we could spread out the material, then we should be able to use one Sweepy to its maximum capacity, which means we can move a lot more through the dock. All right, my second thought here is, can I possibly use a signal counter or something like that to control which one of these chutes is open? All right, here we go. I got a bunch of counters set up. It's looking for a certain element here. This first one always wants to stay on 1. What? Oh no, the numbers aren't really working out. Uh-oh. What? All right, well, so much for that idea. Let's get rid of all that automation. I was really looking for something to use that new automation with, but nah, it's not gonna work. There's an easier way of doing this. The old school way. All right. Yeah, there we go. This is working out a ton better. Look at all these little Sweepies doing their thing, and they're moving a good amount of material. Look at that. Boom. What I'm sort of curious about is why are some of these hot while others are cold? That's still 160 degrees Celsius. What happened to my beautiful set output temperature? Was it because it was in a vacuum? All right, so now we're in a vacuum. No, it's still doing at 159 degrees. What? Okay, does it just have to do with what material the Sweepy bot is made out of? Why is it at 150? What a mysterious thing. I have no idea why some are hot and some are cold. What? Any number of temperature. Nope, I guess it just doesn't really care. All right, well, interesting. Was it because there was liquid in there? Just throw a little water down. It's gonna steam up real quick. We'll mop up the rest of it. We'll go back to filling. Okay, so each one has a little bit of water inside of it. No, that isn't it. All right, so looking back at this, I can see that the temperature that's coming out of here is actually quite hot. So yeah, I don't know. The set output temperature thing from the Sweepy must have been... All right, so it looks as if the temperature that is flowing out of here is actually not cool. I guess the set output temperature of the Sweepy thing was... Maybe it got patched away or something, I don't know. Maybe for whatever reason it was showing up, but it isn't now. The point is, it's not happening anywhere. So I don't think we really need any of this stuff at all. That is not really needed. So let's go ahead and just put the chute right there and call this good. If you have a need for it, you can do something with it. If you want to run it through more steam turbines, you can cool it down even more. But for right now, I'm not going to worry about it anymore because there's nothing else to explore. Okay. All right. So let's take a look at what has worked out here. The Sweepy up here at the top has actually worked out really good. You can put in a lot of magma here. This thing doesn't seem to ever end up underwater or anything like that, so it's not a big deal. And it survives the intense heat of the volcano. So you can actually build this up to be a really big cylinder if you really wanted to and store up lots and lots of magma. That way, so when your volcano goes dormant like it is right now, you have lots of heat that you can use for a long, long time. This little arrangement here with the auto sweeper to go in there and pick up out of the dock works out fantastically. It stays nice and cool with a little bit of a cooling loop that's running behind there as well. That runs on over here to a bottle emptier made of obsidian to withstand the temperature. It runs right down here, and there's a thermal sensor that is set to be below 170 degrees Celsius. That actually works out pretty good here, running a couple of steam turbines. We obviously have a thermal aqua tuner, and that is hooked up just like this to the machine. And I have that set to be above 20 degrees Celsius. So when that loop runs around, the input side of this, can either go in here and out there, which is cooling it, or if it's disabled, it skips on by. The water flowing back out of here from the steam turbines tends to do a pretty good job of keeping them balanced, believe it or not. Obviously, you could take this idea and you can blow it up really big if you really, really wanted to. I think there's room to probably put even more bottle emptiers or different methods that you might be able to think of to get it from here to even more spots. But this arrangement here does work out pretty cool, and that's kind of a neat new thing because I've never used a Sweepy dock to do something like that. There's obviously other arrangements that we've used in the past, like doors or kind of falling off the edges, that really do the same sort of thing, but hey, Sweepy bots are cool. And then right down here, we're obviously using the new conveyor rail sensors here to disable the loader over here, or actually disable the sweeper so that we don't fill up the loader too much and cause it to get too hot. So this allows us to go into that second stage of cooling where we're cooling down the solid igneous rock, as far as we really want to go. We can make this as big as we wanted to and really, really extract a lot of energy out of this if we wanted to. How this automation is working, just to recap, is it's looking for an igneous rock. We flip that using a knot signal and just run that straight to the auto sweeper. Pretty simple. And then that runs through a rail just like this, and we are detecting the temperature over here. I have it set to 400 so that it runs pretty much at the maximum rate up here for these steam turbines. You can see that the temperature of the steam right there is about 192 over there on the right, and a little bit cooler, bouncing between around 150 to 160, maybe even 180 or so on the right side. So this kind of bounces a little bit. The output temperature of this igneous rock right now is at 370 degrees Celsius. The Sweepy bots for actually cooling that down even further didn't actually work out, so you may want to take that and run it through a third set of steam turbines to really get that temperature down to a very low number, something like 150 degrees Celsius or so. Honestly, working with something like this really isn't that terrible. You can do it inside your base, although I would try to get it a little bit lower. You could lower this number, it will slow everything down. The amount of power that we're actually getting out of this is actually doing pretty good. So in the previous cycle right there, we were able to generate 1,900 kilojoules right there before you go and buff it with the power control station. So that's a pretty good number. And the previous cycle before that one was 1,916 kilojoules. So yes, you can absolutely extract a ton of power out of all of this magma right here. And this gives you, I think, some good ideas to kind of work with and expand on. And I don't know, try to solve taming a magma volcano in yet another way, maybe using some Sweepy bots. I'll have a blueprint to this in the description below if you want to download it and give it a try inside of your base. Thanks for watching, guys. Hopefully you guys have enjoyed this little episode here of Oxygen Not Included. If you have some ideas for me, go ahead and leave them down there in the comment section below. If this looks like the channel for you, maybe consider hitting that subscribe button. As always, stay awesome, guys. Peace. Brothgar